x, which is in green right here, and use that equation to find f of x, which is in red. Well, let's do this a step at a time here. We want to first find g of x and use that to find f of x. All right? So, in other words, they already told you which function is your input. Where are we starting? The starting line. And where are we ending as the output, or where are we ending, right? Well, let's get started, guys. To do this, guys, now we're not going like originally. We're not using g of x, f of x inside. We're actually going to create an equation. And to do this, guys, we need to do a little review. We need to review of what is a parent function. Now, a parent function, it's basically the original graph for any type of equation. For example, when you have y equals x, that's the parent graph of the linear graph right there. It looks like this. When you have y equals x squared, that's the parent function of a quadratic. And whatever numbers you add, it moves it up, it moves it down, whatever. You already know those rules. Let's do another one. Y equals x cubed. This is a cubic, and it looks like an S. If I were to give you, it looks more or less like an S going like that. Well, today we're going to review this graph, and I know most of you don't know what this is, but I'm going to give it to you. Our parent function for this one is actually a y equals the square root of x. It's the root, and it looks like this. It's basically like a half a parabola going sideways. So our parent graph is more or less around here. It goes up, 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 and it goes like that, basically. That's the original parent. Okay, so we need to use this parent graph to figure out how to make the g of x and use g of x to find f of x. So let's do it a step at a time here. Let's say our point begins at 0, 0. So we know the parent graph is the square root of x. Now, if you want to move it sideways, remember, there's a minus. With anything inside with the x is a horizontal shift. Everything outside of the x is a vertical shift. You move it up and down, vertical shift. Okay, let's make some space here. So, with that in mind, let's go from the parent to the green one. How many did I have to move up? Well, this point is negative 6, 3. So I had to move up 3 up, which is plus 3. So on the outside, we're going to put a plus 3. There it is. No need for double pluses here. Plus 3. Now, we want to move how many to the left? If I was at 0 and I go to negative 6, I am moving negative 6 because I went 6 left. Remember, the minus is already there with the formula. So in reality, guys, my equation for g is the square root of x plus 6 plus 3. There you have it. Now, if I wanted to use g of 3 to get to what I'm looking for now, well, now let's look at this way. I'm right here. I want to get to the one in red. How many did I move to the right? Well, if I'm at negative 6 and I went to negative 4, I went 2 to the right, which is plus 2, right? Plus 2. But here's the kicker, guys. We need to keep this originally how it was. Otherwise, we will get it wrong. Because we need to focus on these right now. Plus 2, you see? So we know originally we're going to have the square root of x minus negative 4, you see? Now, how many did I have to go down? If I'm at positive 3 and when I get to, that's negative 4, negative 2. From positive 3 to negative 2, I went down 5 down. So if this is a plus 3, I need to go 5 down. I subtract 5. That will give me a negative 2. So my actual graph for f of x is actually the square root of x plus 4 minus 2. Now, how can you always double check your work? I'll give you guys a little shortcut here. If you wanted to start at 0, 0 again, and disregard the green line, let's go straight to blue. Well, our graph says we're going 4 left because it's the opposite, and we're going 2 down. Is that true? Did we, oops, sorry. Are we going 4 left? Yes. And then 2 down? You betcha. And that's how we know this f of x is right.